Space is overwhelmingly empty. But just a few hundred kilometers above our atmosphere, that emptiness vanishes right now. A bustling invisible network of 1,100 active satellites is zipping around the globe. These machines perform the essential duties that keep modern civilization running. They route our global communications, generate the GPS signals guiding ships and planes, and collect the precise data we rely on to forecast the weather. This same zone is also home to our most priceless tools for scientific discovery, like the Hubble Space Telescope drifting high above the blue horizon. We have placed $1 trillion infrastructure in a narrow band of space, right above our heads. Almost every technological convenience of the modern world depends entirely on this fragile layer. Achieving orbit requires moving sideways at immense speeds. Falling around the planet's curvature so fast, you never actually hit the ground. At this altitude, the atmosphere is thin enough that objects experience almost no drag. They can remain suspended for centuries without needing extra energy. Consequently, every discarded rocket booster and dead satellite from decades of spaceflight remains trapped in place, orbiting indefinitely alongside our active network. After decades of launches, low Earth orbit has become a high-speed junkyard. We are currently tracking over 100 million pieces of debris, ranging from massive dead metal cylinders to tiny fragments the size of a marble. At 30,000 kilometers per hour, kinetic energy turns a pea-sized fragment into a destructive plasma bomb, capable of vaporizing solid metal upon impact. Our method of reaching the stars has inadvertently surrounded our planet with a persistent high-speed minefield. Because we keep launching new rockets, the density of orbital junk is growing. We are reaching a tipping point where a collision becomes inevitable. In a hypervelocity collision, objects spray through each other, fragmenting into thousands of pieces. Maintaining lethal speed, this Kessler syndrome generates bullets that fan out to strike secondary targets. The process is exponential. One collision creates 50 and the debris wall multiplies on its own. The existential threat is the unstoppable, mathematical reality of an exponential cascade that fuels itself. A collision cascade would systematically wipe out the 11 satellites we currently rely on. Without them, the infrastructure of the modern world goes dark. Global logistics networks fail, aviation routing completely breaks, and internet communications are severely disrupted. Triggering this cascade would regress our technological capabilities back to the constraints of the 1970s. Beyond earthly convenience, a locked orbit presents an even greater long-term tragedy. A dense, untrackable debris field, moving at extreme orbital speeds, creates an impenetrable physical ceiling around the entire planet. Any rocket attempting to pass through this swarm would be shredded, making further exploration mathematically suicidal. Humanity's greatest technological leap might permanently imprison us on Earth, freezing dreams of lunar bases or Mars colonies for centuries. To secure our future, engineers are developing specific, proactive solutions to dismantle this orbital trap. New capture and return missions aim to remove large debris, using specialized nets and tethered harpoons to snag spinning. Defunct rocket boosters alternatively. Giant electromagnets can push against a dead satellite's internal components, safely guiding it down to burn up in the atmosphere. 4 millions of microscopic fragments, space-based lasers can ablate the surface of the junk, vaporizing enough material to nudge it into a safer orbit. We have a narrow window of about a decade before the density of orbital junk reaches the point of no return. Access to the cosmos is a fragile privilege. If we successfully deploy these jailbreak technologies now, we can clear the way for missions to other worlds.